where we left off yesterday in section 11.2. Sorry about that. We ended up yesterday with simplifying radicals that had fractions in them. And we would give the numerator and denominator each their own radical to simplify. And what happened with once we did yesterday on the last few examples is the denominator ended up being a perfect square. So when I finished my fraction, I did not have a radical left in the denominator. Well, now we're going to see what happens when you do have a radical left in your denominator after you simplify your fraction. Now, a fraction is not simplified if you leave a radical in the denominator. Okay? It breaks mathematical laws if you leave a radical sign in the denominator of a fraction. So, the way we have to do that is something called rationalize the denominator. And I'm going to show you how that goes. So, first of all, if I want to simplify radical 10 over 3, I first have to give each term its own radical. So, I'm going to say radical 10 divided by radical 3. So, I give them both their own radical. And then I see if any of them simplify. So, is there a perfect square that goes into 10? No, it does not. So, radical 10 won't simplify. Is there a perfect square that goes into 3? No, 3's prime. It won't simplify. But I cannot leave a radical in the denominator. I can leave a radical 10 on top, but I cannot leave a radical in the denominator. So the way we have to get rid of the radical is by making a perfect square. So to make a perfect square, we have to do something called rationalize the denominator. So that means you're going to take that denominator and multiply by it over itself. What is anything divided by itself equal? 1. So mathematically, I'm not changing the fraction because I'm just multiplying it times 1. But I am changing the way it looks. Okay? I'm changing the way it looks. All right? So then you multiply across. So you take the denominator, multiply it by it over itself. Okay? Then you multiply across because that's how we multiply fractions. And we learned yesterday that we multiply insides with insides and outsides with outsides. So radical 10 times radical 3 is radical what number? 30. Over radical 3 times radical 3 is what? Radical 9. And that one is a what? Perfect square, isn't it? And that's what you want to happen. So then we see if we need to simplify. Does radical 30 simplify? Are there any square numbers that go into 30? Actually, no. None of the numbers that go into 30 are a square. So you can leave radical 30 alone. And what is the square root of 9 equal to? 3. So you just put plain old 3 in the denominator. And now we don't have a radical in the denominator anymore. Can you see if you can reduce? But you cannot reduce the inside of a radical with the outside of a radical. So this is our final answer. If you had a number on the outside that reduced with a 3, then you could. But you cannot reduce an outside with an inside. Same thing with like multiplying. So if you have a radical in the denominator, you multiply it by it over itself. That rationalizes so that you have a perfect square on the bottom. Take the square root of it. So it's not that bad. All right, the next one, example S, says radical 12 over 5. So what's the first thing we do to simplify this? Give them their own radical. Good. Now, does radical 12 simplify? Is there a square that goes into 12? 4 times 3, right? I'm just going to do it above it to save some space. So that's radical 4 times 3. So that simplifies to what? 2 radical 3. And does radical 5 simplify? Is there a square that goes into 5 besides 1? No, 5 is prime. So we leave it radical 5. But can I leave it radical 5 in the denominator? No. So we got to rationalize it, which means I take the denominator and multiply by it over itself. Multiply it on top and on bottom. And then going across the top, remember you do outsides with outsides, insides with insides. So leave the 2 alone on the outside. And on the inside, what's radical 3 times radical 5? Radical 15. Over what's radical 5 times radical 5? Radical 25. And then you simplify. Does radical 15 simplify? No, so leave it 2 radical 15 on top. And what's the square root of 25? Just plain 5. And then you make sure that fraction, the 2 over 5, will not reduce, and it will not. It's already simplified. So this is my final answer. There's my final answer. Y'all are doing extra cool stuff here. You will use this again in geometry and algebra 2. I promise. Okay. So, what do we do first on T? You give each the numerator and the denominator their own radical. So that's radical 7x over radical 8. Now, some people like to simplify first and then rationalize, but it's okay if you just rationalize first. So we could simplify radical 8. It'll be 2 radical 2. Or we could just keep going with it. I think this time I want to just keep going with it. Is that okay with y'all? So let's just go ahead and rationalize, because radical 7x won't simplify, because 7's prime and x won't simplify. So that gives me radical 8 over radical 8. Okay, so on top I have radical 56x over, what's radical 8 times radical 8? Square root of 64. Good. Now, does 56 have any numbers in it that's a square? I can think of one. 4 times what? 14. So I can change that. I'm just going to leave that x hanging in there because it's 1, so I can't take it down and you simplify the x. So I'm just going to leave it hanging out in there. So 4 times 14x. And I'm just going to keep going across. And what's the square root of 4? 2. So that's 2 radical 14x. And then square root of 64 is what? So I drag that across. And I can simplify one more thing. What do you think it is? The 2 and the 8. So your outside terms, you see if you can simplify. And 2 over 8 reduces to what? 1/4. So I can leave it radical 14x over 4. If you put that 1 on top too, it's the same thing. So radical 14x over 4. Any questions there? So I could have simplified at the beginning and then multiply across with radical 2 by radical 2. Or you could go ahead and rationalize and then simplify later. Whichever one you're more comfortable with. Let's do U and then we'll do T. I don't know why it's so low down there. I'm going to bring it up a little. All right, notice that this time the whole fraction is not under the radical, is it? It's not. So you don't give them their own radical if the radical's not over the whole fraction. You're just going to leave that 2 alone up there. And so what we're going to do is go ahead and rationalize, because 3 will not be simplified and radical x won't be simplified. And you've got to rationalize with the whole thing. So we're going to do it radical 3x over radical 3x. Okay? Well, then I multiply across 2 times radical 3x. Outsides and insides don't combine, so you leave it 2 radical 3x. Right? Over the square root of what? 9x squared. And 2 radical 3x will not simplify yet any, so I will leave that 2 radical 3x over, what's the square root of 9? What's the square root of x squared? And 2/3 will not reduce. I can't do anything with the x's because one's outside, one's inside. So there's my final answer for that one. Any questions on rationalizing denominators? All right, I want you guys to try these two right here. Radical 3/7 and 4 over radical 2x. Obviously, the last one is like the last one we just did. Okay, so on number 1, what did you do first? Give them their own radical. So radical 3 over radical 7. Did any of them simplify as they are? No. So how do you get rid of the radical in the denominator? So you multiplied by radical 7 over radical 7, right? And what did you get when you multiplied radical 3 times radical 7? Over what did you get with radical 7 times radical 7? Does radical 21 reduce in any way? No. So you leave it alone. What's the square root of 49? Did you get this for your answer? Raise your hand if you did. Any questions? All right, on number 4. Can you give them each their own radical? Oh, not on number 4. The next example, sorry. I just saw the 4. Do you have to give them each their own radical there? No, because the top is not included in a radical. So what do you have to do first on that one? Right, you multiply by the denominator over itself. And then you multiply across. What's 4 times radical 2x? Over what's radical 2x times radical 2x? All right, and 4 radical 2x will not simplify, so I'm going to leave it alone for just a second. What's the square root of 4? What's the square root of x squared? Does any of those reduce? 4 divided by 2 equals, and that goes on top. So, yeah, 2 over 1. So, did y'all get 2 radical 2x over x? Raise your hand if you got that. Man, y'all are so smart. I wonder who your teacher is. She must be awesome. Okay, so now we're done with fractions for a little bit. We're gonna come back and hit fractions again in a second. That'll be the last thing we do again is fractions. But let's talk about adding, subtracting, and multiplying with radicals for a little while. First of all, if we're adding and subtracting radicals, we need them to have like radicands. It's like having like terms. Okay? If the same thing underneath the radicals are the same, then they are like terms, basically. If they have the same thing under the radicals, that's called the radicand, right? The stuff under the radical is called the radicand. Then they are like terms, and you combine them like you combine like terms. All right? You add the coefficients or subtract them and do whatever the signs in front say. So problem V is so very simple. It's 4 radical 3 plus 6 radical 3 minus 5 radical 3. They all have a like radicand of radical 3, right? So all you do is add and subtract the coefficients. So 4 plus 3 minus 5. Oh, I can't even read. 4 plus 6 minus 5, right? The terms in front. 4 plus 6 is 10. 10 minus 5 is what? 5. So my answer is 5 radical 3. So you keep the inside the same, just like you're doing x's. Okay? So on problem W there, we have 12 radical 5 plus 3 radical 7 plus 6 radical 7 minus 8 radical 5. So what do y'all think we're going to do there? Yeah, get your radical 5s together and get your radical 7s together. That's it. So for radical 5s, I have 12 radical 5 plus 8 radical 5, which equals what? 4 radical 5. And then for my radical 7s, I have positive 3 radical 7 plus 6 radical 7. So that's 9 radical 7. It's positive, so I say plus 9 radical 7. I'm going to go ahead and tell you, it does not matter if I would have done my radical 7s first and then my radical 5s. Okay? It doesn't matter the order because you're just adding, right? Addition is commutative. That means it doesn't matter the order in which you write it. All right. So those are simple. But look at X. Problem X. 3 radical 20 minus 5 radical 5. They don't have like radicands, do they? No. So if they don't have like radicands, you need to look and see if any of your radicands can be simplified. Meaning, is there a square number that goes into one of them or both of them? So do any of them have a square number that goes into them? Which one? Radical 20 is the same thing as radical what? So that's 3 radical 4 times 5. And I'm just going to keep simplifying that. What's the square root of 4? 2. And since I already have a 3 on the outside, what do? Multiply it. So that is 6 radical 5. Well, now what do you know? They got the same radicand. So I have 6 radical 5 minus 5 radical 5, which equals what? 1 radical 5, or you could just leave it radical 5. So if they're not like radicands, see if they will simplify. So what about y? 2 radical 20 plus 3 radical 45. What's up with that? Can I simplify radical 20? Well, 5's not a square, so I really don't care. All right. Does radical 45 simplify? Yeah, they both will simplify, right? So we already said radical 20 was 4 times 5, so that's 2 radical 4 times 5. I'm going to go ahead and finish that one. What's the square root of 4? Times 2 on the outside is, so that one's 4 radical 5. Everybody good there? All right, then I'm going to work on that radical 45. What's the largest square that goes into 45? 9. So that's 3 radical 9 times 5. And what's the square root of 9? Times 3 on the outside is 9. Y'all are just ahead of me. It's okay. You're fine. So now they're like radicands again. So what's 4 radical 5 plus 9 radical 5? 13 radical 5. So if they're not like radicands, simplify and see if you get like radicands. That's not too bad, is it? No. So now let's multiply with radicals. Look, last letter in the alphabet. Whoop, whoop. See what I start doing after I get to Z? I double them. There's A and then there's AA. Because I couldn't think of what else to do after that, so that's what I did. What does example Z look like to you? Guess what it is? It is distributive property. Okay, so that's what you're going to do. Remember, when you're multiplying with radicals, the rule is you do outsides with outsides. And what else? Insides times insides. All right. So radical 2 times radical 4 is radical what? 8. Plus radical 2 times 5 radical 2. What do you think that's going to be? 5 radical 4, right? Because you got to keep the 5 on the outside because they don't have an outside over there. And radical 2 times radical 2 is radical 4. Then you simplify them. So what's the largest square that goes into radical 8? Radical what? 4 times 2. And what's the square root of 4? So that's 2 radical 2. What about this square root of 4 right here? It just equals plain 2, right? It's a perfect square. So this is the same thing as saying 5 times 2. And what is 5 times 2? 10. Just plain 10, not 10 radical 2, not 10 radical 4, not 10 radical anything, just 10. So are something with a radical 2 and something that doesn't have a radical, are they like terms? No, so that's all we can do there. Okay. So any questions about that? So it's okay if you can't combine them. It's okay. Okay, we just simplify them all the way first. The square root of 4 is 2. You talking about why can't I add these? Because you're not multiplying, you're adding. It's like, this would be like saying 2x plus 10. They're not like terms. So to add them, you have to have a matching radical. Does that make sense? You can multiply different radicands, but you can't add different radicands. Does that make sense? Okay. What does A look like to y'all? Anything familiar? Well, it is. Well, it's in factors. So what was the opposite of factoring? Multiplying, right? And it's a binomial times a binomial. So some of us called it FOIL method. Sometimes we just distributed it twice, right? Right? So basically we got to take this term and multiply it times this one and this one, and then we take this term and multiply it times this one and this one. Okay? That's what we're doing. That's the plan. So 4 radical 5 times 3 radical 6. Remember, outsides times outsides, insides times insides. So 4 times 3 is 12, and radical 5 times radical 6 is radical 30. Then I'm going to do 4 radical 5 times negative radical 10. So 4 times negative 1 is negative 4. And what's radical 5 times radical 10? Radical 50. This is all kinds of fun. Then you do the 2 insides. So negative 2 times 3 is what? Negative 6. And radical 3 times radical 6 is radical 18. A lot of multiplying, isn't it? And then last I do negative 2 radical 3 times negative radical 10. So what's negative 2 times negative 1? Positive 2. And what's radical 3 times radical 10? Radical 30. Because, yeah, it's a lot of extra multiplying because you got to do your outsides and your insides. All right, so there's our multiplying. Now we simplify. Does radical 30 simplify? Are there any square numbers that go into 30? Nope, because 1 and 30 aren't squares, 2 and 15 aren't squares, 3 and 5 aren't, or not 3 and 5. 3 and 10 aren't squares, and 6 and 5 aren't squares, right? There is no square besides 1 that goes into 30, so radical 30 will not simplify. What about radical 50? Yes, what goes into 50 that's a square? 25. So let's simplify that. 25 times 2. And what's the square root of 25? Times negative 4 on the outside is a negative 20, right? So that's negative 20 radical 2. What about 18? 9 goes into it, right? So that's negative 6 times radical 9 times 2. And what's the square root of 9? 3 times negative 6 is what? Negative 18. Well, looky there. I got some like terms, don't I? So my radical 30s, I'm just going to bring them down, because I didn't have to simplify those. And now I've got radical 30s I can combine and radical 2s I can combine. Y'all with me? So what's 12 radical 30 plus 2 radical 30? 14 radical 30. I'm going to squish it underneath here. And then what's negative 20 radical 2 minus 18 radical 2? Negative 38 radical 2. That's really like the longest it should be. And you don't have many of those. You got one at the top and a few on the bottom. Like 4 on the back at the bottom. So like 5 total. All right. So the last thing we have to talk about is fractions again. This is the last thing we're going to do in this section, I promise. All right. This is a fun word. Conjugate. You were very close. Conjugate. Everybody say the word conjugate. Conjugate. Say it again. Conjugate. Conjugate. Okay. Conjugate. Conjugate. All right. Now, y'all. So not only can we not leave we can't leave radicals in a denominator. That's why we need a conjugate. Sometimes our radicals in a denominator have a plus or a minus with them. Okay? So the conjugate is a radical expression with an opposite sign. So the conjugate of 3 plus radical 2 is 3 minus radical 2. So what's cool about those two things? What do you notice? A conjugate, how do I get a conjugate? You change the sign in the middle, right? What's up with the first terms? They're the same, aren't they? What's up with the last terms? The last term are the same, and the middle are opposite signs. So where and before have we seen same first term, same last term, opposite signs? What kind of binomials? Difference of squares. Guess what a conjugate is, y'all? It's difference of squares. Yes! Y'all, that is so exciting. Okay? So here's what the cool thing a conjugate does. Here's what conjugates do for each other. All right? So if I multiply two conjugates together, and we said it's difference of squares, right? And y'all remember difference of squares? We had shortcuts for that, right? Square the first term, square the last term, opposite signs or a negative sign in the middle, right? So 3 squared minus radical 2 squared. Well, let's just work that out. What's 3 squared? 9 minus what's radical 2 squared? What happens with a square and a square root? Cancel out, and it leaves you with 2. And what does 9 minus 2 equal? 7. So what a conjugate does is it takes an ugly radical expression and makes it a number. With no radicals, just a little number. So cool. I love conjugates. They're my friends. Okay, so here's what we can use them for. Here's a problem. 2 divided by 6 minus radical 3. 2 divided by 6 minus radical 3. Can't leave a radical in a denominator, right? And this one has a minus sign with it, so I can't just rationalize the radical 3. I have to use the conjugate. All right, so what is the conjugate of 6 minus radical 3? Oh, yeah. So, just like when we rationalized it, we have to multiply times 6 plus radical 3 on top and on bottom. And I use parentheses because the top part I have to distribute. Okay, so the top part I'm going to distribute 2 times 6 and then 2 times radical 3. So what's 2 times 6? 12. Plus, what's 2 times radical 3? 2 radical 3. Are we okay on top? Now let's do the conjugate magic on the bottom. You just work it like a difference of squares. So you say 6 squared minus radical 3 squared. Difference of squares. That's all it is. So what is 6 squared? Minus, what's radical 3 squared? 3. And what's 36 minus 3? 33. And you just stick that on the denominator. And you are done. And you go on with your bad self. Okay, so you're asking, could I simplify this? And the answer is yes. You could factor out the 2, but that gets you back where you started. Right? And okay, if the GCF would have been divisible by 33, then yes, it would be beneficial. But since both of those are not, the 2 is not go into 33, does not have anything in common with it. Like 12 over 33 would reduce because they're both divisible by 3. But since 2 don't reduce with it, you'd have to do both. So you just leave it like it is. Uh-huh. You cannot because they're not like terms. One has a radical and one does not. Okay. I just think it's so cool. We have 2 more examples in a you try. I'm going to raise this one up a little bit. All right. So what do you think we're going to do to get rid of the radical on this denominator? We're going to use the what? What's the conjugate of 5 minus radical 2? And we're going to do it on top. Yes. So, distribute the top. 3 times 5 is plus 3 times radical 2 is 3 radical 2. Outsides times outsides, insides times inside. You can't combine outsides with insides. So then how do we do the conjugates on the bottom? 5 squared minus 2 squared. And what's 5 squared? Minus what's radical 2 squared? What's 25 minus 2? Stick it on the bottom. 23 is prime, so that won't fix anything. So leave it like that. It's not so bad. This time the radical's in front. No biggie. No biggie. So, what's the conjugate of radical 3 plus 2? Yeah. So it's okay if the radical is in front and not in the back. You just go on like normal. Distribute the top. What's 9 times radical 3? What's 9 times negative 2? Good. And on the bottom one, we do difference of squares. So that's radical 3 squared minus 2 squared. What's radical 3 squared? 3. Minus what's 2 squared? 4. 3 minus 4. Negative 1. Now we could simplify this a little bit. Dividing by negative 1 does what to everything? Changes the sign. So all we have to do is change the signs on the numerator. So we can say negative 9 radical 3 plus 18. If we want to rearrange it, we can say 18 minus 9 radical 3. But I'm okay leaving it like this. Change signs. No. Because it's the same thing as having it over 1. So it just saves a step. All right, I want you guys to try one, and this will be the last one we do together today. All right, so what did you use to get rid of the radical? That's called the what? Conjugate. So you use 5 minus radical 3 over 5 minus radical 3. So what did you get when you distributed the top? 10 minus 2 radical 3. And on the bottom, how did you work out the conjugates? Complete the difference of squares. 5 squared minus radical 3 squared. And what is 5 squared? 25 minus, cancel, 3, which is what? Now this one actually will, you can simplify. Did y'all know that? Because they're both all divisible by 2, right? Right? All 3 outsides are divisible by 2, so you can just divide them all by 2. So, and I didn't show you one like this, but I want to see if y'all figured it out. Since all 3 of the outsides are divisible by 2, you can divide them by 2. So what's 10 divided by 2? Minus what's 2 divided by 2? 1, so you can just leave it negative radical 3 over what's 22 divided by 2? 11. So technically this is the most simplified. Yes. Subtract what? 10 minus 2? No, because they're not like radicands. 10 don't have a radical. On a quiz, yes. On homework, probably not. But your quiz is not till Tuesday. And I think you only have one conjugate problem on there. And I don't think you even have to worry about it at the end. Like, I don't think it simplifies. Okay? So, with that being said, we are going to have a quiz on Tuesday on all of, we did 2 days worth of section 11.2. Monday, we're going to do 11.3. So, if you're not here on Monday, you are taking your quiz on Tuesday because I'm telling you ahead of time. Okay? Got it? Questions? All right. So, I'm going to stop. This is the end of the video. Goodbye.